So these next set of videos are on solving quadratic equations. Now, one of the first things that you want to do whenever you're presented with one of these equations after you write one is decide what kind of equation that you have, because you're not going to solve a quadratic equation just like you solve the linears. Remember, a linear equation, you just get x by itself and you're done. Quadratic, a little bit more challenging here. So it says standard form of quadratic equation is 1. And one variable can be written as ax squared plus bx plus c is equal to 0. And of course, a is not 0. If a was 0 in this equation right here, then 0 times x squared, you just have a linear equation, right? How do I know that this is quadratic? How do I know this is quadratic? I know it's quadratic because it has a highest power of 2. Right? The linear had a highest power of 1. It has a linear term in it, but hey, this x squared term overrides it. It says, hey, I'm quadratic here. And you may recognize that ax squared plus bx plus c from the quadratic formula, which is one of the ways that we have to solve these things. Now you see pictures of some parabolas here where we're expecting to see one solution, 2 solutions, or 0 solutions. So remember, with linear equations, we only get this one solution, just a single dot. But hey, quadratics, we can have 2 or we can have none. And all of those things come out of the quadratic formula as well. Hey, where are you? Okay, there we go. Now, this technically is not the graph of ax squared plus bx plus c is equal to 0. And the reason why it's not is because you need a y in there. You need 2 variables for it to look like this. When you have just one variable, just the x by itself, you're only expecting to see like a collection of dots. 1 dot, 2 dots, or no dots at all. So in order to see this, understand, make sense of all of this stuff, let's first flip over to our green sheet. Hopefully you have that green sheet out. It'll take me a sec to get it, so it'll also take you a sec to get it maybe. I'm going to go ahead and take a look at it. Again, we are on the side that's marked solving linear and quadratic equations. So we had already gone through how to recognize and what to expect from linear equations, and that's the stuff over here on this side of the card. Now we're over here on the right-hand side. We're going to talk about some aspects of quadratic equations, and then the bottom part is basically some techniques that you can use to solve those quadratic equations. Okay. So let's start up here on the top right-hand corner where we have a quadratic if the highest power of any term is 2. That's how I know that this is a quadratic equation. Specifically, this is a quadratic equation that has 2 variables because we have a y variable and then we have x's also. This is the one that when we graph it, we get that parabola shape that's down here. Okay? All right. The graph of a quadratic equation, now we're in this one here, of one variable consists of 2 points on a number line. Now, it's possible you can have just one. It's also possible that you have 0. It depends on where those solutions occur and what that quadratic equation. But I'm expecting at most 2 solutions here. Right? It's the 2 values of x that possibly make this thing a true statement. If I stick in 1 into this quadratic equation, 1 squared is 1, minus 3 times 1 is negative 2, plus 2 more gives me 0, so that works. This one would also satisfy the equation and make it a true statement. Okay. However, if we throw that y in there, we make it a quadratic equation that has 2 variables in it. You don't get those 2 dots. Now you get yourself a parabola. And as a matter of fact, there is a relationship between this graph that has dots on it and this graph that is a parabola, because look at where those 2 dots are. Look at this quadratic equation, y equals x squared minus 3x plus 2. It looks exactly like this one. The only difference is that y is being replaced by 0. But think about that for a second. Where is y equal to 0? On a graph grid like you have here, where's y equal to 0? Y is equal to 0 is right here, but at anything on the x-axis, the y is equal to 0. So that's essentially what we're seeing on this number line graph. We're basically only seeing this picture, although this quadratic, this whole parabola would exist here if I threw in a y where that y is equal to 0. Okay, so this is the reason why those 2 points that are right there that are on the graph here, the two x-intercepts, are sometimes called roots or zeros, because it's where it makes this equation equal to 0. Okay, now what we said when we were talking about a linear equation, it's very simple to solve it because you isolate x. One of the most common mistakes that students make when they solve a quadratic equation is that they want to do it the same way, but you can't. So our general technique is right here. This is so important, but it's also so easy to understand. It's something that everybody understands pretty much almost instinctively. Solve a quadratic equation in one variable, you set it equal to 0, and you apply this thing that's called the zero product property. Zero product property looks like this. If I have two things, pretend these are two numbers that we don't know what they are, but I do know that when I multiply them together, I get an answer of 0. Well, what does that mean? Well, the only way to get an answer of 0 when you multiply numbers together is if one of them is 0, at least one of them. Maybe A is 0, maybe B is 0, or it's possible that they're both 0, right? And so you might associate solving these quadratic equations in one variable with this F word that is called factoring, that we try to factor it. We're trying to put it into this kind of form so that we can set each one of these factors equal to 0, and you can see that play out in this example that's right down here, okay? All right, so a couple more things about this. We've got in standard form, a quadratic equation can be written as ax squared plus bx plus c is equal to 0. That's exactly what we saw on that leading slide there, and we're calling this a value the leading coefficient. It's just a number, whatever it is. It is a coefficient because it's being multiplied times x squared, and it's the leading one because it's on the term that has the highest power. The b that's in front of that, it's still a coefficient. It doesn't really have a special name other than it's the linear term, because it's almost like your slope times x, your linear term. And then your c, of course, is your constant because it doesn't change, whatever that number might be. Okay, and excuse me, and then the rest of this, we're going to take a look at these specific boxes when we get to it within the lessons, okay? Talking about factoring when your leading coefficient is a 1, a specific way of factoring when you have a difference of 2 squares, this AC method whenever your leading coefficient is not a 1, and then finally a foolproof method that always works is using this quadratic formula. Surely you've seen this thing before at some point last year, right? At least that's the hope. All right, so let's briefly go back to the presentation and kind of recap some things. We are expecting when we solve a quadratic equation, 2 solutions, 1 solution, or 0 solution. And what happens here, this means that there are 2 real solutions that you can see that are right here. When we get 0 solutions, this happens whenever we take a square root of a negative number, which is imaginary, and you deal with those things quite a bit in Algebra 2, for sure. Or it's possible that we have 1 solution that happens when we have a perfect square. Like, for example, you take the square root of, you take a square root of 36. That's a plus or a minus 6. But if it's set up in such a way, making this thing equal to 0, you only get 1 solution. We'll see something like that happen in the course of our solving some of these equations in a moment. Okay, so highest power is 2 for that quadratic, and quadratics, when we solve them, we're expecting we can have 0 solutions, 1 solution, or 2 solutions. It just depends on how they are set up. How can we solve these quadratic equations? We basically have 3 methods. We can solve it by graphing. The way that we do that is we graph that quadratic equation and we see where it intersects the x-axis. This is what I was talking about on this green sheet that's right here. You could put this into your equation under y equals, type in that equation, and you're seeing where the x-intercepts are. You're seeing where it hits the x-axis because that's where y is equal to 0, and it turns it into that equation that's right up there. So there's a method that we can use to solve any quadratic equation. We can do it by factoring, and this is going to be like the largest focus here because it's a skill that we definitely want to sharpen, is factoring. We put the equation in standard form, we factor it, and we apply the zero product property that If two things multiply up to 0, then at least one of them has to be 0. This one right here is so incredibly powerful. Whoops, I just marked out the 2 for some reason. It's so powerful that it works regardless of whether you have a quadratic equation or a cubic to the 3rd power or a quartic when it's to the 4th power and so on, all right? Again, stuff that you'll do in Algebra 2 and pre-cal. And then lastly, we have that quadratic formula that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It is the method that the a, the b, and the c are things that you use, the a, the b, and the c that are in the quadratic formula when it's in standard form like this, the numbers from that. And we'll see that as an example in the coming videos. But we're going to pause it right here before we actually dive into a series of sample questions.